another math tutorial. In this video, we're going to look at solving quadratic equations with a new technique called completing the square. This technique is going to allow us to solve equations that are previously unsolvable by factoring and square root methods. So I want to begin with just a little bit of review so we know where we've been, and then that'll take us forward to where we're going to go in this video. So we're going to solve these two equations by factoring. So this trinomial is going to factor x and x to make the x squared. And then we need to multiply to negative 14 and add to negative 5. So we're going to use negative 7 and positive 2. So we get x equals 7 and x equals negative 2. Over here, same idea. Let's get our factors set up. So x and x makes x squared. We want to multiply to 8 and add to negative 6. So we're going to use negative 4 and negative 2. Gives us solutions of x equals 4 and x equals 2. Okay, so that's factoring. We've done that before in previous videos, but just wanted to review kind of that technique. The other technique we have is square root method. So let's take a look at one of those problems. Okay, so your square root method problems look a little bit different than the previous problems we factored. Here we've got this binomial or quantity squared. That's where it's recognizable. Whenever I see that, I'm going to do this square root technique. So I'm going to bring the 15 over. I'll have 1/3 times quantity x minus 4 squared equals 15. I'm going to multiply this 3 or 1/3 over to the other side as a 3. So I'll have x minus 4 squared equals 45. Take the square root of both sides. So x minus 4 equals plus and minus the square root of 45. And then I'll just add this 4 over. So x equals positive 4 plus or minus. The radical can be simplified to 3 square root of 5. Okay, so there's a square root method problem. So we've got factoring and we've got square roots. And today, believe it or not, we're going to kind of merge these two techniques together into one technique, and that technique is called completing the square. Alright, so here's an example of completing the square with steps kind of written out step by step exactly what I am going to do. Now I'm going to use completing the square whenever my other two techniques aren't applicable, okay? Because as we saw, like factoring can be done in just a couple of steps to get the answer. Square root technique, maybe a couple more steps involved, but it's pretty recognizable when to do that. So it's a pretty easy technique to use. Both those techniques are great, but they're very limited in what they can solve. So we're going to do this new technique, which is going to expand on the problems that those cannot solve. So for example, this quadratic, x squared plus 6x minus 3, I would always begin by checking to see if I can factor. So I'm looking at negative 3, and I'm thinking, can I multiply the negative 3 and then with the same two numbers add to positive 6? And the answer is pretty easy. I can't do it, okay? So when factoring fails, completing the square is an option to solve this problem. And so here's kind of the steps. The first thing I'm going to do is I'm going to make sure that I've got an a value of 1. And if you're in this video, you should be familiar enough with the quadratic function or expression to know that when a equals 1, I mean the coefficient in front of x squared. I want to make sure that's a 1 in front of the x squared. And if it's not, I'm going to make it 1. The last two examples of this video have examples of that. But for this example, a is 1. So I can check that step off. Did that. Next, I'm going to isolate the x terms on one side. Okay, so I'm going to begin this, since the first step is taken care of, I'm going to take this minus 3 over to the right-hand side because it doesn't have an x. So I'm going to rewrite this as x squared plus 6x. And now here's a tip. Leave a space in the work. So x squared plus 6x, I'm going to leave room there, equals, and then the minus 3 is going over, so 3. I want to leave room right here after that 6x because next I'm going to go on to step 3, and step 3 is going to have me add half of b quantity squared to both sides. So again, back up to where I explained where the a was, we all should know where the b is. The b is the number in front of the x term, so b is 6. So I am going to add to both sides. I'm going to take half of 6, which is 3, and I'm going to square it. Okay, that's step number 3. Add half of b squared to both sides. Now, if you want to rewrite that step, we could write it as x squared plus 6x plus 9 equals 3 plus 9. So I can just change the 3 squared to its value 9. Now, I'm going to factor the quadratic. So what started out in the beginning was a problem that couldn't factor. I now have a problem that can factor. X times x is the x squared. I want to multiply to 9 and add to 6. I'm going to use positive 3 and positive 3. And over here I can go ahead and put those like terms together to be 12. Now, what will always be true when you do this to complete the square is that these two factors are going to be the same. And so you can rewrite this as x plus 3 quantity squared. That's my factoring step. When I say complete the square, that is completing the square right there. I now have a square binomial, and we know what to do with a square binomial. We can now solve this with the square root method. Okay? So I'm going to take a square root of both sides. And then I'm going to take that 3 over, so x equals negative 3 plus or minus. Now take a look at this step right here. Simplify the radical if possible. And 12 is 4 times 3, so I get 2 square root 3. And step 5 was done when I solved for x. So there's completing the square. Essentially what you're going to do is you're going to take a quadratic that doesn't factor, and you're going to add this term to both sides, and adding that term changes this into a quadratic that does factor. And it's going to factor always into a perfect square that can be solved with square root method down to the end. All right, first step, make sure I've got 1 in front of the x squared, and I do. After that, I'm going to isolate my x's. So x squared plus 10x, leave some room here, equals, and then the minus 7 is going to go over to the opposite side. So I've got equal to 7. Now I'm going to add to both sides. I'm going to take half of 10, which is 5, and I'm going to square it. I'm going to do the same thing on the other side. Okay? I can add anything that I want as long as I do it to both sides, but if I specifically pick this number, half of the 10, it's going to make those factors for me, which is what I want. So now this is going to factor, so rewrite this if you want. X squared plus 10x plus 25 equals 7 plus 25. I sometimes don't write this step because my next line, going to my factors, Here's why I don't always write it. Because these numbers right here, the two positive 5s, are always going to be this number right there. And so sometimes it's actually better for me to see it like this, because then I know exactly what number I'm going to drop down here into each of these factors. Okay? Over here I can put those together to be 32. And then I'm going to have x plus 5 squared equals 32. Square root both sides, so x plus 5 equals plus or minus square root of 32. And then move the 5 over, so x equals negative 5 plus or minus 32 is 16 times 2, so we get 4 square root 2. And that's completing the square. Alright, if you think you've got the hang of this and you want to try one on your own, this would be a great problem to hit the pause button and go at it by yourself, and then once you think you've got an answer, or if you get stuck along the way, go ahead and resume playback and see how you did. So here we go. I'm going to start by grouping or isolating these x's. So x squared minus 4x equals, this negative 4 gets added, so equals 4. Now I'm going to add to both sides. I want half of negative 4. That's a little different this time. Negative 4 is negative 2, and I'm going to square it. And over here I'm going to add negative 2 squared. Okay, this now factors. I'm not going to simplify this time. I like seeing negative 2 because it tells me what to put in my factors. So I'm now going to factor this as x minus 2, x minus 2. It's minus 2's because I'm putting the negative 2 into each of those spots. Over here I've got 4 plus negative 2 squared is 4. So this gives me x minus 2 quantity squared equals 8. Square root both sides, so x minus 2 equals plus or minus square root 8. And then move the 2 over. So x equals 2 plus minus, the 8 simplifies to 2 square root 2. Alright, another example. Again, a great opportunity to pause and try the problem on your own just to kind of check for understanding and seeing how you're doing. I'm going to go ahead and begin, assuming you've either done that or you just want to watch me play this one out from the beginning. So I'm going to group my x's together. X squared minus 12x, I'm going to leave some room, and the 56 gets subtracted over, equals negative 56. Now we're going to add to both sides. Half of negative 12 is negative 6. I'm going to square that. And over here, I'm going to go ahead and skip a step so I can combine these quicker. I'm going to go ahead and just square this. Negative 6 squared is 36. So I've added the same thing on both sides. That's fair to do. Now, let's think about what I've typically been doing. I've been factoring this into two binomials and then going down to the binomial squared. It always does that. Let's just go ahead and skip this step. It's going to be x, and then the negative 6 comes down, minus 6 squared. These two combine to be negative 20. Okay, take the square root of both sides, so x minus 6 equals plus or minus square root negative 20. Add the 6 over, so x equals 6 plus or minus negative 20 is going to be negative 4 times 5, and negative 4 square roots to 2i square root of 5. So it is okay to get complex numbers for solutions, specifically imaginary numbers within your answer when you square root these negatives, as we saw in the previous video. So those are going to be in play. That's going to happen. Alright, the first half of this video I've shown you some very simple, kind of straightforward completing the square problems. Next I want to show you some problems where completing the square is just a little bit harder, and it's only a little bit tougher because you just have to be a little bit better with fractions. Okay, so let's go ahead and take this one. X squared plus 5x minus 2 equals 0. I'm going to begin by isolating my x's. So x squared plus 5x equals the minus 2 goes over to positive 2. Now we're going to add to both sides. This is where it gets tougher. I'm going to add to both sides. I need to do half of 5. Well, half of 5 is 5 halves. I'm going to square it. And over here, I want to add the same thing, 5 halves squared. And let's just go ahead and do that math. 25 fourths. Alright, so I got this to factor. And again, why I leave it like this is because I know that this is just going to come straight down into my factor, so it's easiest to just keep it like that. I got x plus 5 halves squared equals. Now here's where we run into a little bit of heavy lifting. I have to be able to put these numbers together. So the 2, which is like 2 over 1, let's do some scratch work here. 2 over 1 is like 8 over 4, and I can add that then to 25 over 4, and 8 and 25 are going to be 33, and then it's going to be over 4. So you do have to do a little fraction play there, specifically adding fractions with common denominators. Now I can take the square root of both sides, so I get x plus 5 halves equals plus or minus, and I've got the square root of 33 fourths. So let's talk about that square root. That square root of 33 fourths is the same as the square root of 33 over the square root of 4. That's a perfect square, so I can simplify that denominator. So this is going to become x equals, I'm going to move that 5 halves over, and now this square root of the fraction is going to become this. Square root 33 over 2. Now, what you can do, since we have some common denominators on these two fractions, we can put these fractions together. And this is a pretty common occurrence to write this as x equals -5 plus minus square root 33 all over 2. All right, let's do another example where we've got an odd number here in the middle because we can't half that very easily, and so that's going to create the fraction issues that are going to play out as we work the problem. So let's just do one more of these so we feel a little bit better about it when we see it in our problem set for our homework. So I begin by isolating these x's. X squared minus 7x, leave yourself some room, equals 4. We're going to add to both sides. Half of -7 is -7 halves squared. I got to add the same thing over here. -7 squared is 49. 2 squared is 4. So I'm adding the same number to both sides. This is going to give me then x. I'm going to use minus because it's a negative number. 7 halves squared equals. And over here on this side, the 4, which is over 1, has to be rewritten as 16 fourths to add to 49 fourths. So those put together are going to be 65 fourths. Now I'll take the square root of both sides, so we get x minus 7 halves equals plus or minus. If I put a square root on both these, I'm doing this just to show you the step, but I'm going to go ahead and simplify this to the square root of 65 over 2. So I've gone ahead and just taken the square root of the 4 to 2. Now I'm going to move the 7 halves over, so x equals 7 halves plus or minus square root 65 over 2. So I'm going to put those together because I like this as just one fraction. 7 plus minus square root 65 over 2. All right, I've got two more example problems. These two problems are a little bit different in how we get these fractions and the play with the fractions. I think in practice, you're probably going to do a problem like this with the technique that's coming in the next video. But I want to go ahead and show you this because I want to show you that you can solve this with completing the square. And some of you out there are really going to love completing the square. It might end up being your favorite method for solving quadratic equations. So I want to show you that we can do problems like this with completing the square. So I'm going to practice a couple before we end this video. So every problem so far has had a 1 in front of the x squared, and this one's got a 2 in front of the x squared. We got to get rid of that 2. We got to get it off of there. And the way that we're going to get the 2 off of that x squared is we're going to divide everything by 2. So if I divide by 2, I get x squared. Divide this by 2, we get 4x. Divide this by 2, we get 11 over 2. Divide 0 by 2, still 0. So that's kind of our first step, is to divide everything out so that we get a 1 in front of the x squared. Okay? Now, from here, everything plays the same. I've got a little fraction there I'm going to have to deal with, but not a huge deal. To me, anyway. So I'm going to isolate these x's. X squared plus 4x. I'm going to leave some room, and I'm going to move this 11 halves over so it's positive on the right-hand side. Now we are going to add to both sides. Half of 4 is 2 squared. And over here, 2 squared is 4. This is going to factor x plus 2, quantity squared, equals, and now I need to add these together. Well, 4 is the same as 8 over 2, and I can add 11 and 8 now to get 19 over 2. Next, we're going to take the square root of both sides, so x plus 2 equals plus minus the square root of 19 over 2. Now, we have a problem here, and our problem is that this fraction, so let's do this, some scratch work up here. I have the square root 19 over 2, and unlike the last two examples where the denominator was a perfect square, this is not a perfect square. There's a couple ways that I can deal with this, and I don't want to really talk about rationalizing radicals so much in this video because that's a whole separate topic that's going to get talked about in a later video in this course. So let's think about this like we did this here, this 4 over 1, how we created an equivalent fraction to combine these. I want to create an equivalent fraction here that has a perfect square in the denominator. So I don't like the 2, I'd rather it be a 4, like in the last problems, because a 4 would square root. So how do I change this 2 to a 4? Well, I take it times 2, so I need to do the same thing up top. So I'm going to think of this 19 halves as instead 38 fourths, which then becomes square root 38 over 2. Okay, so that's the simplification I'm going to do to that term right there. So now I'm just going to subtract the 2 over. So we get x equals negative 2 plus or minus, and this is going to become square root of 38 halves. Now, I would be okay with you leaving the answer just like that. If you want to modify this, you could very well do this. You could change the negative 2 to a negative 4 halves. And now we made common denominators, and you could get negative 4 plus minus square root 38 over 2. I think it's important to know how to do these little rewriting tricks like that, because if you're doing problem sets, if you're doing assignment problems, sometimes the answer you get and the answer that you check in the back of the book might look very different when in fact they're equivalent, they're the same answer. So I think it's good exercise to go from here to here sometimes, or at least to know that you can go there. Okay, here's the last problem on this video. If you feel up to it and you want to try this on your own, go ahead and hit pause and try and do this one just like the last one. Keep in mind it's got a number in front of the x squared. That needs to get divided off first. If you don't want to do that, you can just watch me work this one all the way out. So the first thing I'm going to do is I'm going to divide by that number. So that's dividing by 3 gives x squared. Dividing 5 by 3, it doesn't divide evenly. I have to leave it as 5/3 x. And let's go ahead and do this two things at once here. Let's go ahead and move this 9 over here. Also knowing that that 9 has to get divided by 3, so it's going to be equal to 3. All right, next we're going to add to both sides. We got to add half of this number. So let's do that as scratch work over here real quick. I want half of 5/3, which is multiplied together to be 5/6. So I'm going to add 5/6 squared to both sides. And actually, I don't want parentheses here. I'm going to go ahead and square that. This is 25/36. Parentheses don't matter, but I just wanted to go ahead and work that part out. Save the step later on. Okay, let's factor this now. Follow the same pattern. X, and then pull in the 5/6 squared. Now we need to combine these two terms. So let's see, 3, we need to make that over 36. So 3 times 36 is 108. So this is going to be 108 over 36 plus 25 over 36. So 108 plus 25 is 133 over 36. Now we can take the square root of both sides. So we're going to have x plus 5/6 equals plus or minus. Now we're putting square roots on both sides. So I'm going to go ahead and simplify this because that's a perfect square. So I'm going to have the square root of 133 over 6. I'm going to subtract over my 5/6. So x equals negative 5/6 plus or minus square root of 133/6. And I want those fractions put together since they have a common denominator. So that's going to be negative 5 plus or minus square root 133 over 6. All right, we made it. We're at the end of this video. Thank you for watching all the way to the end. I really appreciate that. If you have any comments or questions, leave them in the comment section below. I hope you have a great rest of your day, and I'll see you in the next video.